Hi guys, this is lesson 6 in unit 7. We're going to talk about operations with radicals. Before we start talking about radicals and different operations, we need to understand that working with radicals and different operation is not a lot different than working with variables and different operations. So let's refresh our memories on how we work with variables and different operations before we talk about radicals. First example is when we multiply variables, we have x times x squared, and when we multiply variables, we usually do not, I repeat, do not look for like terms. That means all we need to do is to multiply these variables. We know that when we multiply the variables, all we need to do is to add the exponents. X times x squared is x to the third. In our second example, we have x plus x. When we add or subtract variables, we usually look for like terms. Unlike terms is the key factor here to be able to work with variables, to work with adding and subtracting variables. And since these two are like terms, that means that I can add the variables in here, and x plus x is equal to 2x. And the third example, we have x plus x squared. Again, we're adding variables. That means I'm looking for like terms. I'm looking here, I see x and x squared, which is, and these two are not like terms, which means that this expression is in the simplest form. Now I have 5x minus 3x. I'm subtracting variables. That means I need to look for like terms. I have x in the first term, and I have x in the second term. That means that these two expressions or these two terms are like terms, and I can subtract 3x from 5x. 5x minus 3x is equal to 2x. Next example, we have x squared minus 3x. Again, I'm subtracting variables. That means I look for like terms. I'm looking here and I'm seeing x squared in the first term, x in the second term. That means that these two terms are not like terms, and this expression is in the simplest form. In our fourth example, we have 20 plus y divided by 4. If we look at the top expression, it's 20 plus y, two terms that we cannot combine. We don't have like terms, and this expression is divided by a rational number, which is 4. So what we can do here to simplify this expression even more is to break down the fraction into 20 divided by 4 plus y divided by 4. When we divide 20 by 4, that means I end with 5. So I'm going to end up with 5 plus y divided by 4. Now you have to understand that we can break down the fraction into these two parts if we have addition or subtraction in the middle. Let's assume that we have multiplication instead. So 20y divided by 4. This expression cannot be broken down into this, because this is one term divided by another term. 20 divided by 4 is 5, which means the final answer is 5y. So pay attention. You can break down the fraction into two parts only if you have addition and subtraction in between the top expression. Okay, so now we're ready to talk about radicals. So multiplying radicals. Let's take a look at the first rule that we have here. We have square root of a times b. These are two numbers or terms multiplied by each other, and in the previous lesson we said that we can break this expression into radical a times radical b, since these two variables or terms multiplied by each other. So today we're going to work backward. That means that we might be multiplying a radical by another radical, which means that we can have just one radical with both radicands multiplied by each other under the radical. So let's put let's put this into practice. So our first example is radical 5 times radical 3, and again we can work backward. So I'm gonna multiply the radicands. I'm gonna get square root of 5 times 3, and in this case I'm gonna end up with radical 15. And since 15 does not have a perfect square as a factor, this radical is in the simplest form. Now let's talk about adding and subtracting radicals. So let's take a look at the first example. We have radical 5 plus radical 3, and we said when we deal with variables and when we add and subtract variables, we look for like terms. And we said radicals are no different than working with radicals is not different than working with variables. But in this case, we're not looking for like terms, but we're looking for like radicands. So when we have radical 5 and radical 3, that means that we have two different radicands. That means we cannot add these together, and this will be in the simplest form. Let's take a look at another example. We have 4 radical 6 minus radical 6. Again, if we look here, we'll find out that we have the same radicands, which means that we need to think about this the same way we think about variables. So we're going to add these terms together. 4 radical 6 minus 1 radical 6 is going to be equal to 3 radical 6. Okay, we have radical 75 minus radical 3. Again, if we look here, we'll find out that we have two different radicands, but at the same time, this radical can be simplified. Square root of 75 can be simplified. So let's simplify this radical and find out if we're going to end up with like radicands. So radical 75, as we learned before, is going to be radical 25 times radical 3. And I know that radical 25 is 5. So I'm going to end up with 5 radical 3 minus radical 3. And since I have like radicands, that means I can combine these two radicals together, and I'm going to end up with 5 radical 3 minus 1 radical 3, which is equal to 4 radical 3. Okay, now we have radical 25 plus radical 3. I know that radical 25 is 5. This is a perfect square. 25 is a perfect square, and radical 25 is 5. And I'm adding 5 into radical 3. I can't put these two together. I have a rational number added to irrational number, and I have to think of this expression the same way I think about 5 plus x. We usually cannot add a 5 plus x together. That means this expression is in the simplest form. 5 plus radical 3 is in the simplest form. Now let's talk about dividing radicals. When we have two radicals added together divided by a rational number, we said that we think about radicals the same way we think about variables. So what we can do is we can break down this expression into radical A over 4 plus radical B over 4. And again, we can do this only if we're adding or subtracting two terms from each other and then dividing by a rational number. So let's take a look at our first example. We have radical 32 plus radical 2 divided by 4. Now I know that radical 32 can be simplified, and this is not in the simplest form, because I know that 32 has a perfect square factor. So the perfect square factor in 32 is 16, and I know radical 16 times radical 2 is equal to radical 32. So instead of radical 32, I'm going to put radical 16 times radical 2 plus radical 2 over 4. Now radical 16, I know that radical 16 or square root of 16 is 4. So I'm going to end up with 4 radical 2 plus radical 2 over 4. Now, if I look at the top, I'm going to see 4 radical 2 plus radical 2. I know that we have radicands here. Both terms has square root of 2 and them, so I can add these two terms the same way I add like terms. 4 radical 2 plus 1 radical 2 is going to be equal to 5 radical 2, and then divide that by 4. Now let's take a look at another example. We have a plus radical 2 divided by 4. A is a rational number. Radical 2 is irrational number. We cannot put these two together. That means I can break this expression down into A over 4 plus radical 2 over 4. I know that 8 divided by 4 is 2, which means I'm going to end up with 2 plus radical 2 over 4. And this is the simplest form that we can have for this expression. So again, the major thing that you need to know that working with radicals is not a lot different than working with variables. When we add or subtract radicals, we look for like radicands the same way we look for like variables. And when we multiply variables, when we multiply radicals, we just multiply the radicands together the same way we multiply the variables. And then dividing radicals by a rational number, again, if we have two terms added together, we can break. If we cannot simplify the top of the fraction, we can break down the fraction into two parts and simplify it as much as we can.